Let's go ahead and take a look at just a couple of computational examples of using the binomial theorem. One thing that we know is the coefficients always come from the nth row, and in this case, the nth row is always indicated by the power, right? So in this case, the coefficients of these expansions are going to come from row n equals 10 and row n equals 4. Now, especially in the case of n equals 10, we don't really want to compute these because we don't necessarily want to list out Pascal's triangle going all the way down, right? 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. So this is n equals 0, n equals 1, 2, 3. And then we could generate the fourth row for the second one. 1, 4, 6, 4, 1. That would be n equals 4, right? That's how many coefficients we have. We'd have 1, 2, 3, 4, 5 coefficients for this expansion down here. And then for n equals 10, we'd actually have 11 terms, right? But the binomial theorem basically says that your coefficient is going to be determined by the row number and which column it is in, so to speak. I don't know if we can really call these columns. We'll just call each of these here. We'll call this column 1, 2, 3, 4, and 5. So how would we do the 10th row? Well, we'd have to compute 10 combination 0 times, okay, now it doesn't really matter whether you start with x or with y, but I will go ahead and point out that the binomial theorem does start off with x to the n minus j power, and then does y to the j power. So the power of x starts off at its largest right here. You can see that, x to the n, and then the power of x's gets smaller and smaller as the powers of y get greater and greater. So if you think about this, we'd have 10 sets of parentheses, each with x plus y in it. We'd have 10 of these, right? And if you were to, not go through traditional foiling, but if you were to distribute this all out, effectively every value in every set of parentheses would multiply every other value. So at some point you'd get x times x times x times x times x times, you'd have all those x's in between, and you'd get x to the 10th, right? So you'd have an x to the 10th term, and that's what this one is going to be, x to the 10th, and then y to the 0. Okay, so you'll have actually just one of those. If you think about it, 10 combination 0 is going to be 1, because there's only one way you get all factors of x, and that's to get x times x times x, 10 of those, right? Now, to get the next term, which will be x to the 9th, y to the 1st, let's think about this for a moment. Well, that's going to be 10 combination 1. So notice the power of x is dropping, the power of y is increasing. Why will there be, comes out to be 10. So this is 1x to the 10, y to the 0 is just 1, but I usually just write y to the 0. 10 combination 1, there's 10 ways to draw one thing from 10 things. And why is that? Well, if you think about it, you get 9 x's and 1 y. So it could be the case that we have y and then followed by 9 x's, or we have xy followed by 8 x's, or xxy followed by 7 x's. And you can see that basically we can just keep repositioning which set of parentheses that factor of y comes from. In any case, we keep on going. So then we'd have 10 combination 2, x to the 8th, y to the 2nd. And then we'd have plus 10 combination 3 times x to the 7th, y to the 3rd. So you can kind of see, the power here is really just the difference between those components. And then the power here is just whatever this guy is down here. And this is going to keep on going, right? I'm just going to write plus ... Let me erase some of this stuff over here. We don't need this anymore. We'll have plus ... all the way till we get to the point where we have 10 combination 10. And at this point, well, x will be to the 0 power and y will be to the 10th power. And that will be all 11 terms accounted for. Right, we have 10 combinations 0, and then 1, 2, 3, 4, 5, 6, 7, 8, all the way up until 10. So that's going to be 11 terms total. Now for this guy here, right, we are not dealing with x and y, we're dealing with 2x and 3y. These are kind of like this is like our x and our y right here. So it's still kind of like we're multiplying those together. Now the way we would do this is we would say, okay, well we'd have 10, I'm sorry, not 10, we'd have 4 combination 0, 4 combination 0, and then now the x, which is actually 2x, I'll just think about that as x, 2x to the 4th power times the quote-unquote y, which is 3y, to the 0 power. Then we'd have plus 4 combination 1, 2x to the 3rd power times 3y to the 1st power, right? So again, think about this whole unit, this whole entity as x and this whole entity as y. Plus 4 combination 2, 2x squared times 3y squared, plus 4 combination 3, 2x to the 1st, y to the 3rd. Oops, see I'm already going back to using just x's and y's, but what I should have here is I should have 2x to the 1st, 3y to the 3rd, and almost done. Last term, 4 combination 4, which will be 2x to the 0 power, 3y to the 4th power. And then these coefficients here are going to be 1, 4, 6, 4, and 1. Okay, those are our binomial coefficients that we saw earlier, 1, 4, 6, 4, 1. Okay, now we have that. How do we expand these guys? Well, if you multiply something by itself 4 times, it's 2x times 2x times 2x times 2x times 2x. Might have said that one too many times. But basically, each of these values would get raised to the 4th power. So 2 to the 4th is 2 times 2 times 2 times 2, which is 16. So this will actually give us 16x to the 4th. Something to the 0 power will just be 1. Here we'll get to the 3rd power, which will give us an 8x cubed times 3y. Out of this guy, we'll get times 4x squared times 9y squared. Here we'll just get 2x, and 3 times 3 is 9 times 3 is 27y cubed. And then here we'll get times 1 times 3 to the 4th power comes out to 81. Okay, so we'll get 81 y to the 4th power. All right, seems like a mess, but now we can just combine things. So this is just, and these are all added together, right? So this equals, and here we'll just have 16x to the 4th. Here we'll have 4 times 8 is 32. 32 times 3 is 96. So we'll have 96x cubed y. Plus here we'll have 24 times 9. I don't know what that is off the top of my head. 24 times 9 comes out to 216 x squared y squared. Almost done. Plus here we'll get 8 times, 4 times 2 is 8. 8 times 27 comes out to 216 as well. 216xy to the 3rd. And then this last term is just 81y to the 4th. So you see, it doesn't necessarily have to just be an x and a y. It could be anything plus anything. And the process still applies. We just have to be careful to attach parentheses to it. So obviously much easier than having to multiply 2x plus 3y times 2x plus 3y FOIL, and then multiply that by another 2x plus 3y. It's a lot of distribution. Here it's just kind of quick computation, but the structure still applies, and it's exactly what the binomial theorem says.